In this video, we're going to talk about rational functions and expressions. If you remember from the term rational numbers, that means things that can be written as a fraction. So we're looking at functions and expressions that are fractions with x's and numbers and such. So first, let's look at what they look like and talk about the domain. Okay, so an example of a rational function could be r of x equals x minus 4 over x plus 5. Okay, so this is an example of a rational function. We see the fraction. And if we want to talk about the domain, remember the idea here is that we are looking for all of the allowed values of x. So sometimes it's easier to look for what's not allowed. So remember, for fractions, what's not allowed is a 0 in the denominator. We can plug anything else in here. Think of what you can put into your calculator. Anything else is okay unless we get 0 in the denominator. That would be bad. It's undefined. So what value would give us 0 in the denominator? -5 would give us 0 in the denominator. So that means we can have everything except for -5. Okay, so the domain would be everything except for -5, because -5 would give us a 0 in the denominator. All right, let's try another one. Now, we did ones like this before. Now we can do ones that are maybe a little bit more complicated. So let's say we've got like x plus 2 over x squared minus 9. So now we're looking for where the denominator is equal to 0. It might not be quite easy to see here, or maybe not easy to see all the solutions. But one way that you can see them easily is to factor, because if you have factors, it looks like this, and you can get the answer quickly. So let's factor the denominator. This is the difference of two squares, so it's going to factor as x plus 3, x minus 3. Okay, and then we can set this equal to 0 and solve like we did in the previous video, or usually you can just look at this and decide what x can or can't be. So from this factor, I get that x cannot be -3, and then from this factor, I get that x cannot be +3. Okay, if you have trouble looking at it and solving it, another way would be to set the denominator equal to 0, solve that, and then that gives you what x can or cannot be. So if we were to solve this, again, we would solve by factoring. Okay, so we do this, and then we've got something times something equals 0. We can break this up. Okay, and then we would solve each of these equations. So I would get -3, and I would get +3. This is a negative in here. Let me make that look a little bit better here. My negative kind of bled into my equal sign. Okay, so that's the idea there. So if you factor the denominator, you should be able to see what numbers cannot be in the domain. So -3 here, +3 here. If you're ever uncertain with that, set it equal to 0 and solve. And then remember that those are the numbers that are not in the domain. So x cannot be those numbers. Okay, so that's the basic idea for domain. Okay, so now let's talk about simplifying expressions. So we're going to kind of move away from the functions for a minute and just look at rational expressions. So same thing, but not a function, just x's and numbers put together as an expression. All right, so the idea for simplifying is the same as the way that we simplify regular fractions with numbers in it. So let's say that we have something like, let's say we have 6 over 9. Okay, so probably you look at that and you say, okay, I can reduce both of these by 3. Let's remember when you first learn this, or let's remember why you can do that. So when you first learned this, you probably said, okay, 6 is the same as 2 times 3, and 9 is the same as 3 times 3, and then this is the same as 2/3 times 3/3, and 3/3 is the same as 1, right? So you looked for factors of 1 that you could do to reduce. 2/3 times 1 would be 2/3. Okay, so once you do this for a while, then you just say, okay, I can reduce by 3 and I can get the answer. But this right here is the idea that you are actually using, is that if you can multiply by a factor of 1, that you can simplify that. Okay, so this is the idea that we're going to use to simplify rational expressions. We need to have factors. We need to have factors where one of the factors cancels out. You can only cancel over multiplication and addition. All right, so let's say that we've got 4x plus 8 over 6x plus 12. Okay, so we want to reduce this. I cannot reduce over addition, so I can't cancel these x's. I can't cancel the numbers, okay? I need them to be factors like we had up here. So the first thing we're going to do is we're going to look to factor. So on top, I'm going to have 4. I've got a common factor of 4 times x plus 2. And on the bottom, I can take out a 6, and I'm left with x plus 2. Okay, so now we have factors, and any factors that match exactly, we can simplify. So x plus 2 over x plus 2 is the same as 1. So those will cancel out. Then I've got 4 over 6. We reduce that the same way that we reduce numbers, just like up here. I can reduce both of those by 2, and I'm going to get 2 over 3. Okay, so the idea for these is that you're going to factor and then simplify anything that matches exactly. All right, let's say that we've got x squared minus 4 over x squared plus 3x plus 2. Okay, so again, we can't cancel anything here because we can't cancel over addition or subtraction. So the first thing that we're going to do is factor. So the top is difference of 2 squares, x plus 2, x minus 2. And then the bottom, this is a regular trinomial, so we're looking for factors of 2 that add up to 3. So x plus 2, x plus 1 should work. They multiply to be 2, and they add to be 3. Okay, so you're going to do your factoring. You're going to do that super careful because you got to make sure you have the right factors. And then you're going to, now that we have it all factored, now you're going to look for anything that cancels. So x plus 2 and x plus 2 are the same thing. That means that it's a factor of 1. X plus 2 cannot cancel with x minus 2. They have to be exactly the same. So x plus 2, x plus 2. And I'm left with x minus 2 over x plus 1. And again, nothing can cancel here because this is addition and subtraction. Okay, so the basic idea for this is that you're going to factor and then simplify.